Hello, Mr. Ray.
Good day, everyone. How are you guys doing today?
I'm good. How you doing?
Doing well, thank you very much. All right, today is September 17th and Math Foundations. All right, so hopefully everybody had a good day today. And I'm just gonna go and ensure I have your names down, written. All right, so we have Gennaro.
Yes.
So welcome again. George, I see you're
Hello.
there. See the wall there. Clemente,
Yes.
good day to you.
Good day, Mr. Ray.
All right, and Raymond as well. And Veronica. And Daniel C. Good day to you.
How you doing, Mr. Ray?
I'm doing well, thank you very much. And Susanna.
Hi.
Hi, how you doing today?
Good. How are you?
Fine, thank you. All right, I see Stacy. Welcome back, Stacy.
Hello.
How you doing today? And that's good. Then we have Marisol. Welcome, Marisol.
Hi, Mr. Ray.
How are you doing today?
Good, and you?
I'm doing well, thank you very much. All right, and then we have Latavia. Welcome, Latavia.
Good evening, sir.
Good evening. Are you doing well?
I'm good, thank you.
That's great. All right, and then we have Daniel N. Welcome, Daniel N. All right, he may not be there right now. William, welcome, William.
Hey, Mr. Ray.
Good day, how you doing?
Good, and yourself?
Doing well, thank you very much. And Dorcas, welcome, Dorcas.
Good evening.
Good evening. How are you doing this evening?
Good.
That's great. And hopefully you will all have a great evening as it continues. Crystal, welcome. All right, and Salvador.
Hello.
Good day, sir. How are you doing?
Good. How you doing, Ray?
It's good. And I'm just letting in Maceo. Looks like Jacob is trying to get in. Okay, so we're gonna more than likely have people coming in as time goes. So as usual, sometimes.
What about George?
Say that again?
George?
Yes,
Okay.
I got you, George. I got you. You're second on my list.
Okay, you called and I was not. I was still arranging my my laptop.
Oh, okay, yeah. Sometimes I know people are doing something and may not hear me.
Okay.
All right, welcome, Maceo. Today. All right, so today we are continuing with fractions, but before we do that, any questions from any previous homework, anything that you did between Tuesday and today?
Yes, sir. I just this is
Yes.
Latavia here.
Yes.
I just sent you a message. I would like you to do that sum for me because I did it, but when I checked the answer, it was incorrect.
Is that 3/2 subtract 1.5?
Yes.
Okay, so 3.5 subtract 1.5. Well, just looking at that, you should get 2. Did you get 2?
No.
Okay, what did you get?
I get 1. Just for me, because if I subtract the 1, that's 0. If I subtract and the 2.
Okay, so if you're trying to do the second method, is that what it sounds like?
Yeah.
Yeah, if you do it the second way, you just subtract the whole numbers. So you have 3.5, subtract 2.5. So if you subtract the numbers together, the 3 and the 2, you're going to get 1.
Correct.
And what did I say, 2? Yeah, yours a 1.5 or 2.5?
It's 1.5.
1.5, sorry, I wrote 2.5. So if you subtract the 3 and the 1, you're going to get 2 there.
Oh, yeah.
So forgive me, I had written it wrong. All right, so subtract the 3 and the 1 together. 3 subtract 1 is 2.
Yeah.
And then when you subtract the halves together, these two, a half subtract a half is 0.
Yeah. I got it. For some reason, I keep thinking it's just 1 all the time.
Oh, okay, yeah. So just be careful with those ones. Sometimes it could throw us off when we see the actual fractions there.
Right. Thank you.
You're welcome. Now, if you do it the other way, you remember, just turn it into an improper fraction.
Right. Okay, thanks.
You're welcome. I just let somebody in and I forgot to write their name. Hold on really fast.
Hmm.
Beatrice, I think it was. So welcome, Beatrice.
Oh,
And,
thank you.
and I got Veronica. 19. All right, perfect. All right, so any other questions?
I
With
have
the,
one, sir.
Sure.
Yes. I was wondering if you could help me go over this one. It's 7/10 minus 1/5.
Okay, hold on, let me just change the screen real fast.
Okay.
All right, so say it again, 7/10.
7/10 minus 1/5.
Okay, and that's it.
Yeah.
Okay.
For right now, yeah.
All right, so for this one, I'm just letting some more people in real fast.
Okay.
And Sergio and Jacob. So for that one, you want to make sure that your denominators are the same. And because 5 can be multiplied into 10, this one actually makes it a little bit easier. It looks like Jacob's having a look.
Do I multiply here or
Well, you want to multiply the denominator.
to get I'm supposed to get the same denominator, right? So
Right.
So 5 times 2 will be 10, and do I do the same with the 10 or
No, the 10 can
just with
stay
the
the
1?
same because since 5
Okay.
times 2 is 10, you don't have to do anything with the other fraction.
Oh, okay, just leave that
But
alone. Just,
what you do to the bottom, you need to do to the top of the fraction.
okay, that'll be 2. So 2. Okay, so it'd be 2/10
Right, 7/10, subtract 2/10.
minus 2/10.
And then you just subtract just the numerators.
Okay, so that's just 5/10, which would be a half.
There we
Or
go.
half.
It'll be a half.
Oh, okay. See, I have this app that's been helping me. I call Photomath.
Okay, yeah,
And
photo math.
It
I know.
doesn't. Sometimes it helps, but sometimes it doesn't give a proper explanation. It's a little different.
Right. I mean, there
Yeah.
are different explanations, and sometimes they might not even give an explanation. So I know
It
what you
really
mean.
doesn't. Now they're charging like an extra part, like a premium package to get that proper.
Oh yeah, yeah.
I'm
Photo
like, oh
math
man.
came out a few years ago, and first they
I'm like,
won
oh.
everybody's confidence, and then once everyone's confidence was won, they started charging.
Yeah, it shows me how like the steps, but it doesn't explain them. Like, oh, like how'd you get that? It'll
Right.
give you the numbers, but how'd you get it?
Yeah. So
Okay.
it's another one out there called Mathway, but they charge as well.
Matt. Okay.
But Mathway is pretty good because it goes up to calculus.
No.
All right. Anybody else?
Yes, Mr. Ray. I had a question and I did work them out on question 17 and 18
In the workbook?
in the workbook. And I was just wondering if you could explain the distributive law of addition and subtraction.
Oh, they had that in there? Wow.
Yeah, so that's I did have a little bit of trouble with both, but I did figure them out and I did get the correct answers.
Right. I'm glad you brought that up because the book can be tricky. I didn't think they brought that up until later. But
Yeah, no, it's just those two questions, 17 and 18.
okay.
And so I just wanted to make sure that I understand it correctly because I know that's going to be coming up.
Yes, it does come up again. We normally talk about it in algebra. I didn't realize it was in the book. All right, so the distributive law, most of you should know about what like a distribution center is, and that's how it can help you. And so a distribution center distributes goods to everyone. So the distributive property or the distributive law of addition simply means that you can distribute one number into other numbers. So for instance, if I have here, I'm going to use the example that's in the book. If I have 5 plus 7, actually, let me start it off differently. Let's say I have 5 plus 7. What would that give me?
12.
That'll give me 12, right? 5 plus 7 is 12. Now, what if I tripled the amount? What would that be if I times it by 3, if I tripled it?
36.
That would be 36, right? The distributive law says that, well, I can triple it before I work it out. So I can either say 5 plus 7 is 12 and times it, or I can distribute the 3 into the addition. and then add them up. So 3 times 5 is 15, and 3 times 7 is 21. And then I can add them together, which I still get 36. So that's what the distributive law means. It means I can either multiply it last or I can multiply it first. So I can multiply a sum once I add everything up, or I can multiply it before I add it up. But I will still get the same answer as long as I multiply everything that is being added by whatever I am tripling or doubling, whatever the multiple is of the entire sum. And we call that the quantity. So when we get to algebra, we call whatever's in the parentheses a quantity. And I'm just going to write down a name real fast so I don't forget. All right, so for example, number 17 now, if we go to number 17, it says use, so let me actually work backwards first. So that means I can work backwards as well. So I can use that understanding, and it's similar to fractions. I'm basically looking for the greatest common factor between 15 and 21. And the greatest common factor between 15 and 21, if you can do it quickly on your head, would be 3. So the opposite way, and we call this factorizing, is to find the greatest common factor between the two and then pull it out before. So if I divide 15 by 3, I could pull that out, and 15 divided by 3 is 7. Not 7, sorry. 5. And 21 divided by 3 is 7. And I can write the 3 on the outside. So that's how you do it backwards. You're still using the concept of greatest common factor, but you just work your way backwards. And we call that factorizing. So in the example in number 17, they're already showing you what the factor is that they want to have pulled out. So not sure if anyone's copying that. Anyone copying this?
No.
Yeah.
Okay, so just to let you know, I heard one yes. We're just dividing by the GCF
I gotcha.
and write it outside.
Mr. Ray, still repeat that number 16. I am not clear because
Well, we haven't got to, I haven't even done the problem yet. I'm just kind of leading into it.
okay.
I'm just surprised they have this on here already, but all right, so let's go ahead and try number 17. If anyone's copying down what I just wrote, it was a shorthand of everything I said. Dividing by the greatest common factor. The greatest common factor was 3. And we write the greatest common factor on the outside of the quantity. So 15 divided by 3 is 5. 21 divided by 3 is 7. And we write the greatest common factor to 3 on the outside of the quantity. We're going to do this more in algebra. It's called factoring if you want to look it up. Factoring is the opposite of the distributive property. All right, so if I can now move on, I'll do 17 over here. So number 17, we have 105, subtract 40, all divided by 5. Remember, that means before I got this quantity, there could be a number that multiplied into there, that it was distributed, that gave me 105 subtract 40. So that means I can rewrite it. Now, I don't have to go figure it out because they already wrote the 5 on the outside. So they want to see, can you figure out what the two numbers would be now? So basically, you just have to say 105 divided by 5. Because 5 times whatever this number is will give you 105. And 5 times the next number is what will give you 40. So what would those numbers be?
Well, I came up
5
with
times
20,
26
I heard 26. and-
21 minus 8.
and 10.
All right, I heard 2 different numbers there.
My bad. So it'll be 5 times 26 will give you 105. And then 5 times 8 will give you 40.
I heard 26 and 8, and I heard 20 and 8.
21.
That's
21.
I don't know how I
21
came
and
up with 13.
My bad.
My own is 13.
All right, so one of those are right. I'm just going to write down someone who just came in. Andres, welcome. So the actual one is 21, because 5 times 20 is 100. And one more would make that 21. You can always do it on the side just to check. 5 times 21, 5 times 1 is 5, 5 times 2 is 10. So it's 21, and all of you were right for the second one, 8. All right, so we have 21 subtract 8, and then what do they ask from there?
The answer, what they equal to.
Okay, yeah, so then they just want the answer. So you could just quickly do that. 21 subtract 8. To show you a
13.
quick shortcut, 5
13.
divided by 5 will cancel. We're going to learn about that some more. But remember, the fraction bar is division. So you can notice that those 5 will cancel, but they're causing us to enter into some algebra stuff. Because now I got to tell you, if you do that, you can only cancel when you're multiplying two numbers. Like if I had 5 minus 8 divided by 5, I cannot cancel that. The only reason I can do what I just did up top is because I'm multiplying the 5. When a 5 is on the outside of a parentheses, it's multiplication. Any numbers. If I have here like 2, like this, that's multiplication. Somebody had asked me about this before, and I was trying to tell you guys that if there's no plus sign and no subtraction sign in front, it's multiplication. So I might be jumping the gun here, but that's because the book decided to introduce this so early. But
Yeah,
the 5 divided by 5, you can cancel that out. 5 divided by 5. So you see how I cross it out? Right? So basically what you see there is that you have 5 divided by 5. That's that first part. And what's 5 divided by 5?
0.
0.
Not 0.
1.
1.
One.
Right? 5 divided by 5 is 1. And so what we say in multiplication and division is that we can cancel it because 1 times any number is still itself. Right? And if we do it all the time, if I say there's a car outside, how many cars are outside if I say there's a car outside?
1.
1. Right? So I don't have to put the number 1 there all the time. And so what we say is just cancels out. So 5 divided by 5 is just 1 times the 21 subtract 8. Does that make sense?
Yes.
Yes.
Right? And so because it's 1, I don't have to write it. So you're going to see that more when we get to algebra. What we say is it has canceled out. So that means we're just left with 21 subtract 8. And what's 21 subtract 8?
13.
13. All right, and so they're just showing you how you can do stuff a little bit faster. Because sometimes these numbers can be really big. And so when we get to algebra, what we do is we factor it out, then we divide it, and then we simplify it faster. But they're just showing you how you can do it. So when you get to those bigger numbers, you can do that shortcut. So for instance, let's say I had 10,500 subtract 400, right? I can divide something out to make the subtraction easier.
Okay, Mr. Ray, let me give you my own idea.
Okay.
I was thinking use 105 minus 40, then divide by the 5. 105 subtract 40, you have 65.
Right.
Then divided by 5, you have that 8.
That's perfect, but let me write out what you see there. The only problem with sometimes knowing how to do it another way is that you have to answer it the way that they have there. So for this one, in order to get the question right, they want you to drag numbers. So they have the number 6, they have the number 8, they have the number 13, they have the number 20, and the number 21. And what they want you to do, this is an example of what it looks like on the test. They want you to drag the correct number into the empty box. So you will have to know, even though you might subtract it and get 13, they're still going to say, well, you got 2 wrong because you don't have the 21 there and you don't have the 8 there in order to get the 13. That's what you do on the GED test. You literally drag those numbers there.
Okay.
Yeah, I was doing it just like George stated right now, and I knew I had to drag the numbers, and that's where I had to figure it out to fit those numbers in there. And
Right. I'm glad you asked it. I didn't realize it was even in there. So I'm glad you brought it up because that is an important information. It's not in the, like I said, sometimes the workbook brings out stuff that's not in the student book. So the more you practice it, the more you could bring out those questions. Because I'll be honest, I don't always check to see what's in the workbook. And so clearly I need to make sure I cover this in next lessons whenever I teach. All right, so number 18 and number 18 is similar. So we could do number 18 as well. But any questions though, before going on to number 18?
Mr. Ray,
Yes.
I had a little problem and it booted me out, so I'm kind of late in, so I don't know what we're looking at right now. Where are
Okay.
we?
We're on the workbook, page 17, number 17. In the
Okay,
workbook.
awesome. Thank you.
You're welcome. And the question was about how to do it. It was something that you're possibly not used to seeing. All right. So any other questions regarding what we just did? All right. So if there are no other questions, let's try the exact same way, number 18. Now notice, getting the answer is good, but that one has 4 possible answers there that you have to get as well. So if you get down to the last answer by doing 21 plus 56, subtract 28 divided by 7, that's good. But you're still getting 2 questions wrong there. And so in order to get that question completely right, you have to figure out what those other 3 blanks are. And the way to do that is to understand the distributive property. And you have to understand it in order to do algebra, because you're going to do a lot of that in algebra. So it's good that it's come up now. So let's go over this one. And remember, they're already showing you what you're going to be dividing by. They're showing you what the greatest common factor is. What is the greatest common factor that they are bringing out of those numbers?
7.
7, right? They're basically telling you that you're going to divide everything by 7. So they're already doing the step for you. Later on, you're going to have to do that yourself. You're going to have to figure out what the greatest common factor is. There's no different than fractions. It's the same concept of finding the greatest common factor of the 3 numbers on the top, factoring it out, just like how you reduce a fraction. It's kind of similar. You're reducing it. The only difference is you're bringing it outside of that quantity that we call that. Right? If you think of the quantity as being a classroom, and in that class we have 3 students and we got a pizza party, everybody gets pizza if I buy pizza for the class. And so if I was to take the pizza from everyone, then I should be able to show what am I taking out from everyone, and that's the pizza. What do they have in common that I gave? Pizza. So what you're basically looking for in those 3 numbers is what do they have in common, and what is the greatest one that is in common. Now the thing is, it's already done for you. They write the 7 on the outside. So basically 7 times what gives you 21?
3.
3. 7 times what gives you 56?
8.
8.
7 times what gives you 28?
4.
4. That's all you're doing. And now, because the 7 is on the outside, you literally could write this as 7 over 7 times 3 plus 8 subtract 4 over 7. We could separate them. Remember, when we multiply fractions, we multiply straight across. We say 1 times 3 and 2 times 4. So that means we can break it up. We can separate them as well. And that's basically what we're doing there. This was a little commercial. Remember, when we multiply 1 times 3, if I was to write it out, I'm saying 1 times 3 on the numerator, right? If I was to do the denominators, I'm doing 2 times 4. That's what it would look like if I wrote it out, which means I could work my way backwards. If I'm saying 1 times 3 equals 2 times 4, then I can do the step before that and say, well, that means I had a half times 3/4. And it's the same thing here. Because the 7 is on the outside, I can rewrite it as 7 over 7 times the 3 plus 8 minus 4 over 7. And that way it might look a little bit clearer. The 7s can now cancel to 1. The 3 plus the 8 is 11. And 11 subtract 4 is
7.
7.
is 7, right? So we get 7 over 7. And what's 7 over 7?
1.
1.
1. Does that look right? 1 times 1 is 1.
They have I thought the answer was 7. Because there is no 1 when you
Yeah,
drag.
Yeah, the answer is 7.
Oh, sorry. That's
what I
that's
got.
my fault. That's
Yeah.
my fault. I took that 7 off. That messed me up. Hold on, sorry. Hold on. I put 7 times 7. It should have been 7 times 1. That was my fault. Got caught up there. I was trying to show you guys how we did the shortcut last time, but that was last time's shortcut. So let me just stick with what I was going to say, because I wouldn't normally do that. I'll just normally say cancel the 2. Right? So 7 divided by 7. But I was trying to show you how you can separate it.
Yeah.
If you were to separate it, it would have been 7 over 1 times 3 plus 8 subtract 4. So forgive me for that, over 7. And so basically that's what I was trying to show you. And I was going to show you some more stuff, but I just think it's going to confuse everyone. So just forget it for now.
Okay, well, that's enough. Thank you. That's a good explanation. I think
Yeah,
I get
perfect.
that.
Yeah, so we cancel the 7s. Just I got to re-clarify now, because since I did that, I know I might have confused some people. So really quick, let me re-explain just what we did there. So once we pulled the 7 out, what we do now is just make sure that we cancel those 7. So that 7 cancels with this 7. 7 divided by 7 is 1. So we're left with just 3 plus 8 subtract 4. The 3 plus 8 is 11. The 11 subtract 4 is just 7.
Makes sense.
All right, so yeah, sorry about that little mix up. When I rewrote that number, I put the 1 there. But if I explain it that way, we're going to be another class doing that. And we will worry about that when we get to algebra. So for now, just trust me. When you have a 7 over a 7 like that, or an 8 over an 8, you just cancel that. It's just 8 divided by 8. So just in case anyone's a little bit lost, let me just write a few so you can get it. Let's say I had 8 times x plus y. Well, let me not use any x's and y's yet. Let's say I had 8 plus 8, the quantity times 7 plus 3 over 8. That's number 1. Let's say for number 2, I had 13 times 1 minus 2 over 13. And number 3, let's say I had 17 times 81 minus 67 over 17. Right? What happens with those 8s?
Disappear.
They cancel, right?
They cancel
And what
each
would be my
other.
answer?
10.
10. How about this one, number 2?
Negative,
One.
-1.
They cancel, and that would just be -1. And that last part, I kind of didn't leave myself room, but what would happen?
Cancel the
Cancel
17.
17
Cancel, and then you
and
get
subtract.
20, no,
16,
close.
14.
14, yeah. So then we
I'm
get
just waiting for
14.
you to finish writing the number. But
I was waiting for you guys to say it. I was like, I don't want to do everything. All right, so does that make sense now? Seeing how it works,
Yep.
we cancel,
Yeah.
right?
it does. Yes.
All right, and let's just do one more thing, just in case that pops up on somebody's test. What would it be? What would this be if I had distributed the 8 back in? So
means
8
multiply.
times 7 is what?
56.
56 plus what?
3.
8 times 3,
Plus 24.
24 over 8. So that's what it was before. I can factor out the greatest common factor out of 56 and 24 to make it an easier calculation. All right, what would it be? What would the step before that be if I distributed the 13 in?
minus
13
26,
times 1 is
13.
13 minus
26,
26, all divided by,
By 13.
all right? And for the last one, you're going to need a calculator for that, or work it out on the side. And that's just going to take us some time. So I'm just looking for my calculator.
13,
I don't know where it is. I might have to work it on the side unless somebody has their. All right, 17. This is going to be 810 plus, trying to do it in my head.
1377, sir.
Thank you. Save me some time. 1377 minus.
Oh, geez.
10.
Anyone working it out for us or no? If not, I do. 7 times 7 is 29.
1139.
All right, thank you. Save me some time there. 1139. All right, so that's what it would look like before. So in the left column, you had 56 plus 24 over 8. We can factor out doing the opposite of the distributive law of addition, and then cancel that 8. 7 plus 3 is 10. And same for each one down there. All right, so that's something good. I'm glad it came up because that would have thrown off a lot of people if it came up on your GED test. Any other questions dealing with the workbook or any of those worksheets that I sent?
I got all the worksheets done, and I didn't have time to do the workbook, but now it'll be easier that you teaching us how to do it.
Well, that's good. I'm glad it came up. Thank you, Daniel, for bringing this question up.
Yes, Ray, I got a problem with number 12. It's 1/512 plus 3/1/3. Couldn't get the answer.
Number 12?
Yeah, on the adding and subtracting fractions.
For, you said number 12.
Yeah.
Okay, I think we did number 12 already, but I'm guessing, who's asking?
Huh?
Who just asked me about number 12?
William.
Okay,
William.
I'll just do it again. We did number 12
do
on
it again.
Tuesday, but I'll do it one more time. Repetition deepens the impression. So number 12 says, how many miles did Luke ride on the weekend? The weekend is Saturday and Sunday, so you're gonna have to add 24, 5, 6, plus 18 and 2/3. And doing it the method 2, I believe, would be the fastest way here. If you prefer method 1, that's fine. But just multiplying this by 2 on here, you get the same fraction. And then you can just have 24, 5, 6, plus 18 and 4/6. That's a 6. Right, just add the 24 and the 18 together. That's gonna give you 42. And the 5 and the 4 is gonna give you 9, 6. But that's still a mixed number. Remember, mixed numbers, there's really a plus sign in between, so that can just help you with the addition part. 6 goes into 9
Once.
one time with 3 left over 6. You could change it to a half right away,
Yeah.
or you could do the steps. So divide each one by 3, and so then you have plus 1/2, and then just add the whole numbers together, and that's 43.5 for number 12.
Mr. Ray,
Yes.
okay, please once more, the law of distribution. I see the circle, the 3 and 5. Could we multiply?
Say that again. The law of distribution.
Yeah, the law of distribution, addition
So
and
what-
subtraction. I'm talking about the 3 and 5. We should multiply those 2 number figures.
You're talking about the example.
Yeah,
And so what are you asking in particular?
the 3 and 5, and they are circled. Does it mean that we multiply?
Oh, okay. So what it's showing you is that you're factoring it out. So
Okay.
what they're showing you that because both the 3, like this, they don't show it here, but basically you had 15 plus 21. And so they're just breaking it down first. So the first step, this is the first step, they just show you that 15 and 21 has a common factor, which is 3. That's the greatest common factor between the 2 of them. So they just break it up to show you that 15 is equal to 3 times 5, and 21 is equal to 3 times 7.
Okay.
Since they both have a common multiple, you can just take the common multiple outside and then add it later. So that's what we were doing just now. But this is just showing, this is just breaking it down. I just skipped that step altogether, and I just went to here.
Okay, thank you.
Mr. Ray,
That's the inside step. Yes.
will we be going over this a little bit further down the line? Because
In algebra, we'll be doing it. I didn't expect it to come up in this unit.
Okay, yeah, because I've been able to do a couple of exercises from the book, but since I logged in a little bit later, I am so lost with this. I'm trying to put it all together, but yeah, I am.
Okay, everybody.
I missed a pretty significant chunk of what you were explaining at the beginning to understand what's going on.
Okay, hold on real fast. I'm just gonna find a worksheet on this. I'm gonna look a little bit distracted because I'm looking on Google right now. But apparently you guys need to know this, so just bear with me. Jacob, are you trying to get in on different devices?
No.
Okay, I have 2 Jacob Wallersteins trying to get into the class right now.
I tried twice to get in, yeah. One of them didn't allow me to, so I just closed it all up and I tried again, and the second time you allowed me to come in.
Oh, okay, so the devices are still trying to get in, or something's happening. I just got a notification saying that you're trying to get in. All right, so just like I said, everyone, I'm just going to get a worksheet that deals with all of this stuff right here, just so you guys could practice it some more.
Perfect.
Of course, it'll take a while.
Mr. Ray.
Yes.
Yeah.
Go ahead.
I having kind of a lot of problems with my I think internet connection,
Right.
and I miss most of the words you say.
Is choppy?
Yeah, I keep looking on the screen to following the wherever you write it down. But I have multiple questions.
Oh, mercy. Yeah, I was having, I don't know if it was your class or different class, but what happened, I got kicked out altogether earlier this week for like 20 minutes, but everyone, you know, stayed in and waited for me. My internet had actually gone down. All right, so it looks like I'm gonna have to create one. I thought I could just find a worksheet really fast, but they don't seem to have them on the just readily available. So I might
I'm
just
gonna
have to, go ahead.
Yeah, I'm gonna try to work with the workbook to understand a little bit. I don't want to bother you to repeat it because obviously it's not gonna work because you cut it up a lot. And if not, I don't know if you allow me to email you my questions.
Yeah, I mean, if it's a question that I haven't done already, I could do it for you real fast.
Yeah.
So
Okay.
what's the question? Because it looks like I'm going to create a worksheet for you guys.
Well, most likely I get late because I get off from work and I have to run to the computer and made it in time. Today I didn't, and I kind of missed the beginning.
Oh, okay. So
And
you missed that part.
yeah, so just try to understand the process and and I mean on the problem.
Okay. I'm gonna create a worksheet on it, and then I'll send it out. And then Sergio, you can let me know what trouble you might have with it. That way, I could really tell who's having trouble with this section.
Okay.
I don't think you see much of it. Actually, let's just do it. Because the thing is, as I was sharing with some of my other students, GED is stepping it up. And if you understand what I mean, they are increasing the cognitive ability that they're testing you on. So they are trying to see, do you understand these properties and these rules? So I'm just going to create some right now, and let's just see if you guys could do them.
We
All
should
right,
try
so
to hurry up and get it done as quick as we can.
say that again.
I said, so we should try to hurry up and get the test done as quick as we can.
Oh, wait. You think? I don't think they're going to increase it that fast, but I mean, clearly they're expecting you to know this. So, all right. So starting with number one, let's say I had 4 subtract. Wish I had my calculator, make it easier. Here we go. All right, hold on real fast while I just do something. All right. All right, let's just stop there for now. All right, so what we're gonna do is something similar. I'm just gonna write it out similar to what they had. I'll do one more actually. Let me see, 6 here, and I'm gonna have, all right, so I was making these up, so it takes a little while just to think through it. And this is a 2 right here, so let me just fix it. Still didn't come out right, but hopefully everybody can make that out. I'm trying to write a 2. For some reason, my screen is messing up. Okay, there we go. So we're going to do the same thing here. We're going to use the distributive law to simplify the following fraction. And I'll write out a portion of it for the first one. The second one, I want you to see if you can guess it yourself completely. But for the first one, I'll write it out for you. And like I said, the second one, I want to see if you guys can do that. So 7 times blank, the box there, subtract the box divided by 7 equals to what? All right, and then the second one, I want you to figure it out completely. Right? I want everything, the box on the outside, the box on the inside, box here. And then the last thing here, should I give it to you? No, I let you guys brain work. So box plus box. So it's a little bit harder than what's in the book.
Mr. Ray.
Yes.
So on the very first one, right after the equal sign, before that parenthesis, you put already a 7. It's because it's the inverse. We are dividing by 7, so it will be multiplying. What's the multiple of 7 that will
give you
7
84.
by what gives me 84?
Right.
That's why you put that 7 up there?
Got it? Yeah.
Okay.
It's very similar to the book. They're giving you the first step. But because that's in the book, it's very possible number 2 and 3 could be on the test. So let's just practice that real fast. I was hoping to find a worksheet on it. Yeah.
So, can I give you the first answer or no?
Well, I was gonna send it in the chat. Or you could go ahead. I won't tell you if it's right though. I'll just hear it.
Okay, so
I want to give everybody
I
a
got
chance.
8.
All right, you got 8.
Yep.
Telling me what happened.
All right, anybody else?
Yes, I got it too. So the first one in the box is 12. The second one is 4. Because 7 cancel out 7, so I got 8.
Okay, so I have 2 8s and an explanation for the 8. And just giving everybody a chance before I confirm, yay or nay with that. Latavia as well as Dorcas. And okay, so has everyone tried? Is everyone trying it? I see some people thinking there, yeah. Now, if you have finished number 1, go ahead, try number 2, but notice I did not give you the starting number. And I did that for number 2 and 3. So number 2 and 3, you actually need to come out with it. All right, I see some answers popped up. Veronica and Adriana have sent me their 3 answers. And Latavia as well sent her answers in.
Okay, I think I understand it now.
Okay, so far I see 8, 4, 10. I see 8, 4, 5, and 8, 4, and 11. So the first two numbers, we're getting the same. The third one, we have some different answers. So I still haven't confirmed that the first one is correct, but I did want to give everyone a chance to try it. All right, I got some more. All right, let's start off with the first one. I got a good bit of answers. Question?
No, I got my answers. I didn't send them. I just tell you the first one, but I'll wait. I
Oh,
got
you
them
can say what were your answers since you didn't send it?
So first I got 8, the second I got 8, and the third one I got 10.
8, 10, and 2?
No, 2 8s and 1 10.
Okay, 2 8s and 1 10. So the different answers I have are 8, 4, and 10, 8, 4, and 5, 8, 4, and 11, 8, 8, and 10.
That's right. That's mine. 8, 8, and 10.
All right, well, let's start going over these then. And if you haven't sent an answer in and you still want to, you still can do that. But I will start it, and let's go ahead. So remember, the 7 on the outside represents a factor, a greatest common factor. Remember, we learned before that factors are the opposite of multiples. And multiples is multiplication. So the opposite of multiplication is
Division.
division. So that means when you find factors, you are dividing. That's just using implication, using logic. That factors are the same as division, dividing a number. So if there's a 7 on the outside, and we learned that the distributive property is to take a number that's on the outside of a quantity that's being multiplied, and I can multiply it in, then the opposite of that would be to divide it to take it on the outside. Since the 7 is on the outside now, and they're equivalent statements saying that they're equal, that means that the first term must multiply to get 84. And if they multiply to get 84, that means I could say 84 divided by 7 to find out what it is. And what's 84 divided by 7?
12.
12. Let me change the color. 84 divided by 7 is 12. And what is 28 divided by 7?
4.
4. Remember, these 7s, what will happen to them on the outside?
Eliminate them. Cancel them.
Eliminate it because it literally means 7 divided by 7. So 7 divided by 7 is 1, and 1 times any number itself, so we don't need to write it. We don't say 1 car, we just say there's a car. We don't say 1 person, we normally just say there's a person outside the door, right? We say there's a house over there, right? There's a cat. We don't say 1. It's the same in math. We don't have to write the 1. And so we just say it cancels all together. So that means all we need to do is say 12 subtract 4, and what does that equal? 8. Right? So we can quickly do that. Sometimes that way can be faster if we factorize it. And you see as we go higher up in algebra that sometimes doing this method really comes in handy. All right, the second one, I did not put a box on the outside. Never assume that this is always going to tell you what it is. It so happens that it does here. Right? So
that might change. Because that was one of my questions. It doesn't mean that the 7 or the 8 or the 6 below the line, it's indicating that it's going to be the same number that's going to go on the top.
That's
to get
right.
all these factors. Okay.
Yeah, it doesn't always indicate that.
Huh.
Because technically, you could take out a 16. You still get the same answer. It's just that you will notice that if let's say you chose 16 here, you still get the same answer eventually. But if you notice that 16 can be brought out, that means 8 can be brought out, which will make it a little bit easier for you because the 8's
right. Okay.
Right, so I'll show you after it's with the 16 just to show you get the same answer. But for this case, we'll notice that these are factors that have in common 8, 16, and 4. But if I choose an 8, what will happen with the 8?
Eliminate. Cancel.
Eliminate. So this is where sometimes
Ah,
choosing a factor can be better than the greatest common factor. And I did throw that in there, but if you chose the greatest common factor, it's still going to come out correct. So if we choose an 8 so that it cancels, then 8 times what gives me 96?
Well,
Wow.
12, and 8 times what gives me 64?
8.
8, and what's 12 subtract 8? Because those 8s cancel.
4.
I heard 2 different answers there.
4.
4. Right, so that one will actually be 4. Now let's say you actually followed the directions and you did the greatest common factor, right? If you did the greatest common factor between those two, I think even 32 can go into both of those. Let me just check. Yeah, 32
Yes.
can actually go into both of those. So you could put 32 on the outside. And what is 96 divided by 32?
3.
That's 3. I'm just going to erase that real fast and change the color. So that would be 3. That's going to be, not 3. What did I say we took out there? 32?
32.
So 32, that would be 3. And what is, how many times does 32 go into 64?
2.
2 times, right? And what's 3 subtract 2?
1.
1. Now, this is where choosing the factor would be better. 3 subtract 2 is 1, but remember the fraction bar means to divide. So what's 32 divided by 8?
4.
4. And remember, you're multiplying. What's 4 times 1?
4.
wow.
So you still get the same answer. What they're doing, they're just trying to see, do you understand the hierarchy of numbers, how numbers work out? And so apparently,
Why would we do that way if we could have gone easier the other route instead?
Right?
well, because what they did, if you look in the book, they chose prime numbers as your denominators. So that's what I did with the first one. I chose a prime number so that you only had one route to take. With the other ones, I chose even numbers because that's possible. You could get a possible different ones. And I did that because if they're asking you this, more than likely they're going to ask you about other combinations that can pop up with numbers. And so I want you to see that no matter what combination comes up, you're always going to end up with the same answer.
okay.
All right. Any questions about that one?
No.
You could have done it with 16. Let me
That's
show you
good.
real fast what would have happened with 16. 16 is also a factor. It is not the greatest common factor, but it's still a factor. If I had chose to take out 16, what's 90? How many times does 16 go into 96?
6.
Right, 6 times. How many times does it go into 64?
4.
4.
4 times. And what's 6 times 4? I'm sorry, 6 subtract 4.
2.
2.
2. And what's 16 divided by the 8 right here?
2.
2.
2. And what's 2 times 2?
4.
4. Right, so you still get 4 no matter what. Now, the only reason why it's different for these is because these numbers were prime. And prime numbers only allow for one scenario to happen. All right, so we're going to stick with the one that works. And just to kind of give you a heads up at number 3, there's an easy way to do number 3. And do you see what the easiest way, sorry, that's not an 8, for number 3 is? Being that there's a 6 on the bottom.
Yeah, choose a 6.
If you choose a 6, that will make it the easiest thing to do there. 12
Okay.
can go into all of them as well, but what will happen if you choose the 6?
You can eliminate them at the end. It'll be easier
You
to
can
get your
eliminate,
answer.
which would be, right, there we go. And that's going to happen in algebra. In algebra, you're going to see that sometimes choosing a factor and not necessarily the greatest common factor will assist you. So although 12 will work and still get you to the answer, choosing a 6 so that it cancels out will allow you to work it out faster. So if I choose a 6, what would be left inside? What would be the first number?
6.
6. What is the second number?
8.
8. And the last number?
4.
4.
4. And 6 plus 8 is?
14.
14. And 14 subtract 4 is?
10.
10. So your answers there should have been 8, 4, and 10.
So they're both right. We just have to know both one or more ways to get our answer, right?
That's, yeah, and GED is known for increasing that concept to see, do you understand different ways to answer questions now? So I'm glad this came up. I didn't realize that they had this in Unit 1. I figured it was just in Unit 2 alone, but they clearly just threw that in there, and I'm glad it did. I just want to check real fast in the student book in their review section just to see if they have a similar question. So just, that's what I'm doing real fast. All right, that's interesting too. So all right, I have a question that I want to go over, but does anyone else have any questions, any other questions?
No.
No, thank you. That's way better. Thank you
All
very
right,
much.
I'm actually glad, Daniel, you saw that, because that would have shocked a good bit of you, I think, if that came up on the test and you hadn't seen something like that before.
Right.
All right,
Thank you
so
for explaining.
I'm glad you guys were listening. All right, let's look at I was just looking through the book just to see if they had anything else, and I saw something else that popped up that could cause some issues, and that's number 66 on page 23 of the student book. So you're going to the student book, that's the blue one. So
You said
close the
page
workbook.
23?
Page 23, yes. Now, page 23 is part of what we call the unit review. It's only in the student books. So in the student book, no matter if it's math, language arts, science, or social studies, at the end of this, each unit in the student book is a review section. That's, and normally I don't tell you about it to the end of the unit, but because they had that question there, I just wanted to see if they had any more like that in the books. But while I was looking, I saw number 66, and we didn't really touch on this. And the fact that it's there means that we should touch on it. So let's go over number 66. First, I'm not going to show you how to do it yet. I'm going to read it to you and then explain to you what undefined means, and then see if you guys can figure it out. So number 66 in the book, I don't have this picture readily available. It's somewhere in my files, and it'll take too long to try to find it. So hopefully everyone has a student book. Page 23, number 66. Student book. All right, so once again, if you read the directions, it says read each question and use the drag and drop options to complete each answer. So that means if this is a GED question, you're gonna have to click the box and then drag them there, and that's how they grade it, just like the ones we just did. They're gonna grade your ability to see the equivalencies of numbers. So number 66 says select two numbers that render the following fractional expression undefined. I briefly talked about this at the beginning of Tuesday's class. So if you weren't there in the beginning, you missed it. It says, note that there may be more than one possible answer. Do you see that? Just like how we had the more possible solutions, here there could be more possible answers as well. Different number combinations can work. Now, first of all, what does it mean to be undefined? Anytime you have a 0 in the denominator, we call that undefined. The reason why, the fraction bar means to divide. So if I have $6, can I divide $6 amongst 0 people? No, it doesn't even make sense. You'd say it to a child, the child's gonna be really confused, right? They can't even comprehend something like that. And we call that undefined. So that means for number 66, they're trying to see, can you create it, right? Can you, from the number choices that are there, create a condition where you can get a 0 in the denominator?
Oh. I think I kind of see it.
Now notice that you can put multiple boxes in there. They allow you to put boxes in the numerator, and boxes in the denominator.
So the one that would really get us to where we need to be would be the box in the denominator. What number we choose, because on top it really doesn't matter what number we have.
All right, you're thinking.
So-
You said that, Jacob? Or
Yes, sir.
Salvador?
Yeah.
Okay, that is correct. And since you said it, I'm just going to go right to it because we are working on time. So did everyone hear what Jacob said?
I don't get it.
Yes.
Well,
Say that
Jacob,
again,
can you explain it again? George had kind of asked a question, so I'll let you explain it again.
So to get this undefined fraction, we need a 0 as a denominator. So down here, that's the one that is relevant. That's the one that we need to focus on and find something that divided by 2 minus 6 will take us to 0. So that's the number that we need to focus on, because on top it really doesn't matter. We can have a whole bunch of numbers and whatever the amount might be. But the one that we really need is this box on the bottom to make it to get to 0.
There's only 3, if that's the case.
Yes, I guess it is 3. 2 times 3 minus 6.
Right.
Awesome.
All right, did everybody hear that?
Okay.
Combination between Jacob and I think that was Dorcas who answered as well. So as Jacob said and Dorcas confirmed, you could have 5 minus any number. Doesn't matter what number you get up top, right? No matter what number you get up top, it's still a defined fraction. But as Jacob stated from right here, the only way that a fraction will be undefined is if a 0 is in the denominator, which means the real focus, the one that you really got to make sure you get right, is 2 times something subtract 6. So what has to be here in order for you to get a 0 in the denominator?
3.
3.
Right, and that's what they both stated, that if you put a 3 there, you're going to get 2 times 3, which is 6. 6 subtract 6 is 0, and that will make it undefined.
Nice.
Now, the reason why it could be many different selections, you could put anything up here. You could put 180,000, right? Even though that's not a selection. 5 subtract 180,000, it doesn't matter what's in the numerator. What matters in this case of what makes something undefined is whatever makes the denominator 0. Now, that's an important topic because later on in algebra, we're going to do something called rational functions. And with rational functions is built off of this concept right here of the undefined. If anyone interested in higher level math, if you're interested in science or technology, this comes back often. So actually, I'm glad that that we went. Daniel, I'm going to put it all on you. I'm glad Daniel first asked that question. That allows us to look more deeper into the concepts that they want you to know.
That's right.
All right, let's do another one like that. See if you guys really get it. I'm gonna throw a doozy in there though, so be ready for
Uh-oh.
it. I was gonna put number 4. I don't know why I numbered this number 4. This number 4 came to my head, but whatever number you want to call that, if you have it in some number fashion, just change it to 5, 6, 7. For some reason, 4 came in my head. All right, so for this one, I'm not going to write out the instructions. Same instructions. Select the numbers that will make this fraction undefined. And like I said, I am going to throw in something a little bit more challenging. Let's see. I'm going to have 6 times a box minus box over .
Seriously?
Yeah, right?
Uh-oh.
Put it this way, if you were paying attention to what I said, when we were doing the number 17 and number 18, I think, or 16 and 17 from the workbook, It can help you out there. I said it over and over. And then when I was trying to explain it, I said, oh, I need to erase this. This just going to confuse everybody. So let me just take it off. It was around that time. So if you could think back to that, I had mentioned something there.
So I think you gave us the answer.
So remember, for this one, you're seeing what would make this undefined. What number? And you could take the number choices. I guess I could make it a little bit easier. So I'll give you some choices. You can choose a half. You can choose a third. You can choose 2. You can choose 3. You can choose 4. You can choose quarter.
Mr. Ray, let me ask this question.
Yeah.
This is number 4. You put 6. Then I saw the square box. Then under, I see 1/3. And the square box -1. What does it mean?
That means a third times some number, subtract 1.
To give, okay.
So 1 times 3 equals 3 under 3. So that's 1 minus 1 equals 0.
Who said that?
Okay, so that the number, the answer will become 0. Then, okay.
So am I correct or no?
Maybe.
If we're doing fractions, we do 1 times 3 equals 3 on the top, and then you slide the 3, so that's equals 3 under 3. That's equals 1 minus 1 equals 0.
Okay, just because of time, that is correct. Well done.
That's right. Now, can you explain it?
Yeah.
Write it down. Okay, let's see.
Yeah, I did give a challenging one, but if you listen at I don't know if you want to try it again, Salvador. Do you want to try to explain it one more time, or do you just want me to go? I do like to you guys.
It's up to you. So when you say the fractions, the same number on the top and the bottom is equals 1. So if we times 1 times 3 equals 3, and you slide the 3, that's 3 over 3. That's equals a single number. So that'll be 1 minus 1 equals 0. No, the one on the bottom be also a 3 because we just slide the 3. Or do we move that 1?
Well, I was writing it out incomplete. So this is what you mean, right?
Right.
Right.
So then it'll give us 3 under 3. That equals 1 minus 1, right?
Right.
And that equals 0.
There we go. That's correct. Well done. That's correct. So what I don't know if you guys remember that. Remember I said that when you multiply straight across, right? So that's what we're doing. 1 times 3 is 3, and 3 times 1 is 3, right? Is everybody cool with that?
Mm-hmm.
Well, remember I also said any number over itself cancels out to just 1, because any number divided by itself is just 1. And so Salvador noticed that it has to be 1, it has to be 1 subtract 1. So he thought about, well, what times a third will give me 1? Oh, if I times a 3 on the top and a 1 on the bottom, I get 3 over 3, which is 1.
Okay. And I know and that might be relevant or whatever, but the options that you gave us over here on the side, which of those options would be the answer for the box? Drag the 3.
Drag the 3. Now, why is 3 the option? Because any number can be written as a fraction as that number over 1. So 3 over 1 is the same as 3.
Okay.
Right?
That's true. That's true. Yeah, that's true. Okay. Thank you.
All right, let's do it again. I don't know why I had 4, but I'm just going to continue it with number 5. And this time I'm just going to write the denominators. And you can write anything on the top. All right. So once again, same rules. And really, we're just worrying about the denominator. What number for each of those denominators would make it be undefined if you put it into that box? Same directions as what you saw in number 66.
So in this particular case, it's just every number that's on the bottom, right? I mean, in the fraction, in
Yeah,
all those.
basically, but be careful of the last two.
Yeah, on 7 we have a -1.
Okay, so okay, that's a
Over
minor. I
5.
didn't see that. I didn't see that one.
That's crazy.
It may or may not change something. It may change something. So this even brings in the integers that we learned. Now that I see that they're asking questions like these, then we're gonna just up it up just a bit. Okay, so what about the first one? Anyone got the first one already?
It'd be 4/1 again.
4/1, right?
Yeah.
Let me change the color. Right, it would be 4/1 because if we were to multiply this, remember you multiply straight across. 1 times 4 is 4. 4 times 1 is 4. So you have 4/4 subtract 1. And what's 4 divided by 4?
1.
1. And 1 minus 1 would be 0. And that will make it undefined in the denominator. So that means you would have a 0 in the denominator if you had 4 as an answer. And remember, 4 can be written as a fraction as 4/1. All right, how about number 6?
5/1.
I heard
5/1.
5/1, I heard 5. All right, does everybody see that? If I had 5/1 and I multiply, remember we learned how to multiply fractions on Tuesday. If I multiply straight across, I'm gonna have 1 times 5.
5.
5, and on the denominator, 5 times 1 would be 5. Subtract 1. And 5 divided by 5 is 1, and 1 subtract 1 would be 0. And 0 in the denominator would be undefined. How about number 7?
Number 7, I got 2.
I hear -2, but if I put a,
2.
say that again?
+2.
As you add +2 in here?
No, sorry. It's -5/1. But the answer I got is +2.
So is that the correct choice to make the denominator 0?
No.
All right, so keep thinking. It's not that difficult. Look carefully at what I done there.
-1. Because now instead of subtracting 1, we have to add 1 to take us to 0.
Okay, but what would this answer be if I multiplied it? Don't overthink this one. Look carefully. What changed in this one?
We have -1.
And what did I do with the second thing?
+1.
Say that again. Yeah, it's a +1. So do you see anything?
Oh, so we could do the same thing that we did, and it'll be, it'll be like -5/1, and then we multiply, we end up with -5 and -5. So that'll be a -1 times +1 equals 0.
Close, very close. Let me just help everyone there. Because it's already negative, I don't have to do anything. It's basically the same answer as the number 6. Because when I multiply this, I'm going to get -5 over +5. The -5 over +5 is going to give me -1. And when I add it to the 1, I'll get 0.
Minus 5/5, it gives you -1.
Right, a negative. Remember, we did this in
Okay.
integers.
Yeah.
So integers was less than 3. That was the one right before fractions, and we learned the negative times a negative is a positive, and a negative divided by a positive, right? So you guys see, those rules can always pop back up mixed in with another lesson. And you will see that as you progress. So let me explain this one. Notice there's a plus sign there, it's a minus sign there. There's a negative sign here, it's a positive there. So in reality, it's still the same thing.
So all we really had to do is find a number that would be plus that one that equals 0. So obviously we want to find a -1, correct?
Right, so all you have to do is just do the same thing because of that negative that's already there.
Okay.
I'm challenging your brains today, so that's a good thing.
Well, number 8 is -6.
Who said that? All right, Veronica, that is correct. It is -6. That's -6, and great observation. That's basically what we just did here. We combined lesson 3, the lesson before fractions, and the stuff that we just revealed here in the workbook and the unit review. And so, yes, that will be -6 or -6/1. It's the same thing, because when you multiply that fraction, when you do the numerators, you're going to get -6. On the bottom, you get +6. That's going to become -1 plus 1, which will give you 0. And I can't write it there because it's in front of the page, but -1 plus that 1 would give 0. All right, play around with this over the weekend. Put a big asterisk next to it. Say this was brain exhausting. Which is good. Think of it, if you work out, think of it like you ran into Arnold Schwarzenegger in his heyday and while he was like in his 20s, and he was going to give you a workout routine, right? That's what today's lesson was, Arnold Schwarzenegger day for your brain. So you want to review it. Never, ever, whenever you get into something challenging, ever, never go and never look at it again. Say, whew, done with that lesson. I ain't looking at that again. You do that, you don't have it. But if you practice it, review it, look at it, try to understand what we did today. Today was a very conceptual based lesson, and you know, I wouldn't have went over it. And once again, I thank you, Daniel, because now I see I need to go over this with my other class. That this stuff can pop up on the GED. And one of the principals at the school, she's a math, both of them are math teachers. And one of them had came to me and said, do you know that they had this on the GED test? And I was like, no, I didn't. I'm glad you told me, right? So it does seem like they do edit it a bit. And part of that reason is we are in 2020. And every year we become more technologically advanced and more logic is required based off of the skills. You know, pretty soon, Amazon might have automated everything, automated trucks, drones, delivering stuff. And as one of my mentors told me, pretty soon you're gonna have to know how to repair a drone and repair electric cars and automated technology. That's the way the world's going. So, you know, part of that
Mr. Ray,
increase.
Mr. Ray, a quick question, Mr. Ray. Does every individual, like let's say all of us in the class, take the GED test? We're not all going to get the same test, correct? There's going to be different versions of it.
It's different versions, but they're tested over the same concept.
Correct. Okay.
So, for instance, one of you might get something like this, number 8. Somebody else might get something like number 66 without a fraction.
Correct.
Then when it gets to the one that you asked, you might get the one with the fraction, and somebody might get the one with the whole number. So they switch it up like that. Like where one day you get a fraction for a question, and you're like, man, this one's hard. You ask the person, they're like, no, mine was an integer or a whole number. And you're like, that's not fair. But then they say, well, I had a fraction for this one. And you're like, oh, I had a whole number. Right? So they switch it up. Anything's possible. But the thing is, they want to, do you understand the concept? Okay, so what we just did here basically is what we call a reciprocal.
Reciprocal, okay.
It is also known as inverting a fraction, right? The inverting, right? So if I invert a fraction, So the reciprocal of 1 or 1 over 5, the reciprocal of 1 over 5 is 5 over 1. Now the reason why we call it inverting is because it's the inverse or the opposite of that.
Okay.
Right, so and we are actually doing it, we say it's inverting, but it's known as the inverse. Right, so the inverse of 1/5 is 5 over 1. So basically you're flipping the fraction. Now remember, that was the rule that we did with keep, change, flip. Do you guys remember that? Keep, change, flip. We keep the first fraction, change the sign, and flip the second fraction. Well, the art of flipping that fraction is doing the opposite. It's the inverse. So we are inverting the fraction. We're going to be doing a lot of that as we go forward. And so that was an example of how to figure out how to do the inverse of something in order to get a specific answer. And so we were inverting 1/5, we was inverting 1/6 so that we can get to the final answer. So if you look closely, whenever you invert any number, you always get its opposite answer. And so, invert
Mr. Ray,
5 over 5, you get 1 as your answer, which we call the identity. Yes.
So Mr. Ray, on those worksheets that you said that we didn't get any division, like to you know, like change the numbers, invert the numbers, multiply and get our fraction divisions. We didn't get any of those on the worksheet. We got additions, subtractions, and I'm not sure what else, but we didn't get any divisions. And I think that was the last thing you taught us last week.
Yeah, I thought it was. I have to check it again, though. I shared it with the other class, so I just possibly left out a worksheet. I thought I sent you all of them, but I'll check over it and send you guys.
We got like 4 or 5, something like that, but we didn't get any on any of the divisions.
All right, thanks for the update. I'll definitely make sure I send you guys some more. And with that, let's try some division. Today is gonna be a challenge day. So with this challenge, we're gonna practice some division, but I'm gonna give it to you differently as sometimes it pops up on test. I call it A here. What if I have 4/5? We call these complex fractions. I'm just going to challenge you guys' minds today. What would we do here?
Is that a division?
It's a fraction bar, and what's a fraction bar?
Divide.
Right.
So yes, you are correct.
So we find a common denominator?
Well, I mean, you
that's
could.
it. We're adding on this one. We'll invert one of the numbers, and then we'll multiply. In our answer, it's our division.
Who said that? Right? Salvador?
Yes.
Salvador, you're on a roll today. Yes, that is correct. What you said.
Okay.
And I was trying to test your ability based on what we have covered. And let me just be frank with you. A lot of tests do that. They will test your ability to reason with things that you already know. Think of it as I blindfold you and I drop you off somewhere in Fontana and I take the blindfold off. If you could find your way home without a phone, without any GPS or map, it will prove how well you know Fontana. A lot of times that's what tests do. They will give you something that you have never seen in a workbook, that you haven't done in class, and they're going to test your ability to reason through the problem. And that's what happened in that question you asked about Daniel. So let's look at it. What Salvador said is correct. Did somebody have a question? Did I hear somebody? All right, so what Salvador said is correct. What we see here is 2 fractions, and we call these complex fractions. But what you'll notice, there's a giant fraction bar there. And Salvador said it, but I'll ask it again. Who remembers what I said the fraction bar really means?
Divide.
Divide, right? So that means if I reason through this, just using words, I have 4/5 divided by 2/3.
Mhm.
Right? That's literally what is written there.
Yep.
I have 4/5 divided by 2/3, which I could rewrite in this format. Now with this format, what did we learn was a way that we can tackle this. I gave you an acronym.
Yeah.
Yeah,
the
invert the second fraction.
Invert the second fraction, but remember the word invert means to do the opposite. So if I invert the second fraction, what must I do? Something else to balance it off.
Put the 3 on the top. And
Yeah,
the 2 on the
I
bottom.
will do that, but something else has to
Multiply.
happen. I have to multiply. The moment I invert,
my bad. Yeah, okay.
because I'm doing the opposite, I have to change that sign to multiplication because I done the inversion. Now that's exact, like this theory, everything we're doing here is literally how algebra works. Algebra works off of the concept of knowing how operations work within each other and how inverse operations work. And so we will do the opposite. What you did there with that, what we did with the denominator and undefined, that is literally algebra. I don't know if you noticed it. The only difference between what we did in number 16 and 17 in the workbook and number 66 in the student book is that instead of boxes in algebra, what do they write instead of boxes?
Letters.
They have letters there. Instead of those open boxes, they put X's and Y's. Literally, that's what algebra is. Algebra is just trying to figure out, based off of what you know, can you work backwards and can you do other different operations? So the fact that I see them asking you that, I'm like, all right, we need to just up the ante a bit. All right, so once we do that, what is the rule for multiplying fractions?
4 times 3.
4 times 3, which would be
12.
12.
And 5 times 2, which would be
10.
10. But we do not leave answers like this in GED.
So that'll be an improper fraction.
And improper fractions we can turn into
Mixed number.
mixed numbers. And how do we do that? I see an answer from Dorcas, I believe. Let me check.
Divide 12 over 10. So that'd be 1 and 2 over 10. And you don't want it like that. You want to minimize it. So
1 1/5.
1 1/5. And Dorcas has sent that answer in as well. Thank you, Dorcas. That's correct. Remember, the way that we can figure out how to simplify that is to divide it by the greatest common factor, which was 2. And so we get 1 1/5. All right, I know I'm expanding your brains today. I'm giving you guys some wrinkles. You know, the more wrinkles in your brain, the more information you know. So today, I think I've possibly given you guys about 10 or so wrinkles, which is a good thing. All right, now the way to keep those wrinkles, you want to study this information and practice, practice, practice. Explain it to somebody. I'm pretty sure there's someone in your household or your friend circle that has never seen anything that we've done today, right? Try to explain it to them so you keep it there. If you don't, it's going to go, right? I will try to, we will bring it back up. You will see it in algebra and you will see it in geometry. That's why a lot of people struggle with geometry and algebra, is mainly because we don't often go as deep as we can with arithmetic. All right, let's try another one. Let's see if you guys could just do it from start to finish. Let's say I had 2/3 and I divided that by 1/4 as a fraction. Go ahead, start it from start to finish. Can you work out the final answer?
Dos sobre 3. Boom.
Got it.
All right, so I hear one person's got it. Is that Salvador?
Yes.
All right, what do you have? I won't confirm it, but I just want to hear what you have.
2.
2, only 2?
Yep.
Okay, so I have 2 as an answer.
Yes.
George, did I hear you?
Yeah, I have two, 3, 2 10.
You have 2 2/3, George.
Yeah.
I see
That's,
2 in the
that's what I
chat.
got too. I
Right,
said
too.
Dorcas.
Me too.
Dorcas, all right, I see yours in the chat. William, you said 2 2/3 as well.
Yeah, 2 2/3.
Jacob, 2 2/3.
2/3.
All right, Daniel is confirming the same, 2 2/3. We got a good bit of 2 2/3. Latavia. So Salvador, I would say check your work just to see. I haven't said yes or no. You
I
guys
got it.
two?
I got it. I added the 3 and the 1 instead of multiplying it. My bad. So I got
Okay.
2 2/3.
I was just going to say everyone who got 2 2/3 to check their work, but you're changing your answer, and I'm seeing multiple 2 2/3 coming in. Actually, change that. I have a 6th and the number 2 again. All right, so let's go over it. Can somebody dictate to me what does this mean?
2/3 divided by 1/4.
Here we go, right? When you see something like that, you don't get scared. You go and say, I know what that is. 2/3, that's a fraction. That other fraction bar is division, and that's a quarter. So that I'm saying 2/3 divided by a quarter. Once I do that, what's my rule?
We invert.
We're going to invert what?
Invert the second
The
fraction.
second fraction.
Invert the second fraction. But if I invert the second fraction, can I leave division there?
You multiply.
Multiply.
No, we
Multiply, because I'm doing the opposite. Inverting is doing the opposite, right? We just saw that when we were dealing with number 66. So since I'm inverting that fraction, I need to invert or do the opposite with the division. And so it changes to subtraction. Right, once we do that, now we know the rules to subtraction. Multiplication. What are the rules to multiplication of fractions?
Straight across.
Multiply straight across. So what would that be?
8
over 12.
8 over 3. 8 over 3, right? We multiply straight across. So 2 with the 4, 3 with the run. I'm going to write that one out just to make sure everyone understands that one. So it's 2 times 4. We multiply straight across. Numerator with numerator. Denominator with the denominator. And so 2 times 4 is 8. 3 times 1 is 3. But that's a problem. Why is that a problem?
Improper fraction.
It's an improper fraction. In the GED, we do not leave fractions in improper fraction form. So what must we change it to?
A mixed number.
A mixed number, right? We want to get the vocabulary down, because if they ask you a term, you want to know exactly what they're talking about. So that's an improper fraction. GED only accepts proper fractions and mixed numbers. So we need to change it to a mixed number. And how do we do that?
Divide.
Divide, right? So 8 divided by 3, or how many times is 3 going to 8?
2.
2 times. How many left over?
2/3.
2 left over, right? Now, I remember somebody had some issues with that. So remember, if you're having some issues doing it in your head, you can write it out. Remember the order switches. So 3 first, and then the 8. 3 goes into 8 2 times. 3 times 2 is 6. When you subtract those 2, you get a remainder of 2. Remember the way to write it out? It's the quotient. The quotient is your answer, plus the remainder. I can't fit remainder in there, but remainder over the divisor. That's what a mixed number is. And so my quotient is 2. My remainder is also 2. And my divisor is 3. And remember, a mixed number is really the addition of a whole number with a fraction, but we don't write the addition sign. So just 2 2/3. And that's the way you do it if you cannot do it in your head. Or if the numbers are a bit difficult to do in your head, you do long division, remembering this rule here, the quotient plus the remainder over the divisor. And that's what a mixed number is. All right, so all of this stuff, if you're practicing that, as long as you're continually practicing, and also trying to explain it to somebody. If you don't have anyone to explain it to, just go over trying to come up with explanations. Even that, like as a teacher, when I first started my teaching school, I did it as a master's. They put us in what we call a cohort. So it was like 25 teachers or people training to be teachers. And we had to just reading a message that came to me. just to let you know, I didn't send out a message, so it must have been Zoom. Must have done that. So you should know who I'm talking to about what you just sent me. I didn't send it. But anyhow, with the cohort, you have to is basically regular people, and they throw you right into the fire. You have to get up there and try to explain something, and that's hard if you're not used to doing it. And you get up there and you're like, all right, so there's a number there, and so yeah, you just do that and do this, and then people are like, well, what's this? What's that? Right? The very art of trying to explain step by step how to do something causes you to learn it. It's human nature. It will happen. Studies show it. People who've done it will give you experience of how it happens. It just happens. So even if you're by yourself, try to explain it so easy that a child can understand it. So that's why you hear me ask you, what do you do next? The very act of you trying to answer my questions is a process of learning. So if you've been quiet, start answering. So I say, oh, you know what, I'm gonna give him an answer. Even if you keep it muted and you try to answer, that's fine too. But just keep practicing, keep trying to answer, keep giving the explanation. And before you know it, you're gonna shock yourself and you like tear the test up. You get like 190, you'll be like, whoa, I didn't even know I could do this, right? Just keep doing it. All right, let's now, we're done a lot of conceptual stuff. Now we're gonna actually just go and practice some stuff. We don't have much time. And so we're gonna go to page 8 and page 9 in the workbook. These hopefully will be a little bit more applied. And before the night's out, I am going to specifically choose one that stumped my other class.
You said page 8 and 9 from the workbook?
From the workbook, yes. And so before the night is over, I definitely will touch on number 6. So
page 8 and 9. So we're going back.
Yes. The reason why we were so far up, that we were looking at was the unit review. The unit review goes over all of the lessons 1, 2, right up to 7. Right now we're on lesson 4. So we have 3 more lessons, and at the end of lesson 7, there's a unit review that goes over every single lesson and puts all the different types of problems together. And normally what I do is at the end of the lesson, I assign that as an assignment. If we were in class, we would actually do it as a test, but it's kind of hard to do a test online. So, all right, so let's go ahead and try number 1. It says there are 2, these are easier. Hopefully this should be a breeze now that we've done all those higher level questions. Number 1 says,
okay. We're in the workbook? Yeah, we're in the workbook?
Student book.
Oh, okay. You said,
Did I say
yeah,
workbook?
you said workbook.
You said workbook, yeah.
My apologies. Throwing everybody off. No wonder you were asking, did we go so far back?
Yeah, we're going back. Like, what's
Sorry about that. Student book.
Well, this is basically lesson 4, right?
Yes, lesson 4
Yeah.
is student book.
Okay, which was our homework a couple weeks ago. All right.
Well, normally I give the homework in the workbook.
Right.
But the student book is normally what I have in class.
Let me change that.
So we're on the student book, page 8, correct?
Yep, student book, page 8, number 1. All right, let's go ahead and do this one. It says there are 2 containers of milk in Eric's refrigerator. One has 3/5 gallons of milk. The other has 3/4 gallon of milk. How many gallons of milk are in Eric's refrigerator? So before you try it, what operation are we doing?
Addition.
We're adding.
Right. So go ahead and see if you guys can get the answer to this.
I sent mine in already.
Okay, let me check yours, Dorcas. All right, so you're saying, I won't say it aloud yet, but I see your answer. Okay, and I see another answer as well. And also make sure that your answers match the multiple choice that's there as well.
5:15.
The answer is C.
4:20.
All right, I hear a C coming up.
3 por 4, 12. 20.
Okay, I'm just gonna step out real fast. I'll be back. Just send your answers in the chat.
Es 27. 20. Voilà. 1, 7, 20.
All right, so I got a multiple answers looking like C is the ones that we're gonna have there. And just for time's sake, C is correct. So number we are adding, as you said, so we have 3/4 plus 3/5. What must we do here to add fractions? What
Find
has
a common
Common denominator.
denominator. There you go.
denominator? What is the greatest one? That
20.
20.
So we multiply each one by basically each other. So 5 times
4.
4, and what you do to the bottom?
5 times 4.
To the top, and 5 times 4 is what's set over there. All right, so once we do that, we're gonna have, what are we going to have?
12 over
plus
20.
15.
Okay, we're gonna have 12 over 20, and I heard 15 over 20. Right, and when we add those two together, what do we get?
27 over 20.
27 over 20.
7 over 20, but that is an what type of fraction?
Improper fraction.
Improper fraction.
And what do our answers need to be in?
Mixed number.
Mixed
Number
number.
form if they are improper fractions. And so 20 goes into 27
One time.
one time with
7 remains.
7 left over.
And 20.
20.
All right, and so that's how we get that answer there of 1 and 7/20. All right, any questions there?
No.
If you did a slight mistake, just make sure you find where you might have went wrong. And if there are no other questions, I'm about to move on. I'm not sure if anyone needs that. If you do, please let me know before I change the screen. In 3, 2, and 1. All right, so let's looking at the time. We're gonna try, what time, 7:47? Let's try number 2, because number 2 is something we haven't had the opportunity to do yet. So I'll read number 2, you can read along with me. If this was a GED question, it would be one of those drag and drop, which means you have to have the answer that they have there. So if you do it a different way, you might not get the same answer. So be careful of the drag and drops. It says, in a water relay race, each team must fill a cup of water, race over to a bowl, and pour the water from the cup into the bowl. The relay is over when one team has filled its bowl to the top. The table below shows the results of the race. So here you see the team in the first column. In the second column is the capacity of the bowl. So team 1 has a half, team 2, 1 out of 1 or a whole, team 3, 3/5, team 4, a third, and team 5, 4/5. So then they ask you, starting with the first place team, list the order in which the various teams finished. Remember, in order to be first, it says that you're looking to see who has filled the bowl to the top. So you're looking to put them in order from greatest to least. So which team would go first?
Team 2.
Team 2.
2. I hear team 2. And that's unanimous. So what you would do there, you click and drag team 2. Right, let's say that's team 2. You click and drag it to the first position. All right, who would be next?
Team 5.
Team 5. I hear team 5.
Team 5.
Is that a unanimous decision?
Team 5.
And why?
Team 5.
Okay, team 5. And why are you guys choosing team 5?
because there's 4 out of 5, so it's almost, if you're looking at the pizza, you almost ate the whole pizza, you only left one slice, so it's almost like the 1.
All right, that's a great analogy there. So team 5 is taken out as well. Okay,
Mr. Ray.
Yes.
When I went over this, I took each and every one of the fractions and I wrote them down and I got their common denominators. And once I got their common denominators, because you can use a little bit of common sense, like my friend was explaining right now, but I got stuck when it came to 1/3, comparing 1/3 to what would that one be? So I had to bring them all.
Right.
I had to go through, and then I turned all of them, found their common denominators, and now it's just plain as day. It lets you know how many equal parts of the denominator, and now you can put them in a decent order.
Right, and actually that's what I was going to suggest. I figured most people would get to a trouble at the last 3, and I'm glad you brought it up. If you heard what Jacob said, that is the way you want to tackle it, because these numbers are relatively easy. If they had given you something like 7/8 and 15/16 and 27/28, that's where it's going to get a little bit more challenging. And so you do want a method that will always work. And so if you heard what Jacob said, the best way to make sure that your method works is to get all the denominators to be the same, finding the greatest common factor and getting those denominators the same. But let's see how many of you guys are able to follow suit and see if we have to change that as we go. What would be the 3rd team in this order? And thank you, Jacob. That's what you guys want to do. What would be the 3rd?
Team 3.
Number 3.
Yeah, team 3 would be
Team
next.
3.
And then how about the last 2?
Team 1 and then team 4.
Team 1 and then team 4.
No, team 4 then team 1. I'm sorry.
I heard team 4 and then team 1, or team 1 and then team 4. Which one?
Team 1 and then team 4.
Yeah, 1 and then 1 and 4. I'm sorry, I got them backwards.
All right, so that's correct, and that the way that it is now, team 1, team 4, and that's because a 1/3 is less than a half, right? But the key, though, is what Jacob said. You do want to know how to do that.
We should do that. Let's go that way. Let us see.
Yeah, I want to show you what that would look like. You want to find the greatest common factor between all the denominators. So if you look, you could do 10, but 3 doesn't go into 10. So that means because 5 can go into 10, 1 can go into 10, 2 can go into 10, and 5 goes into 10, you just need to now find a common denominator between 10 and 3. So what's a common denominator between 10 and 3?
30.
30. So that means if you change all of them to 30, then you can compare just the numerators. And so what times, let's start with the top number. 2 times what gives 30?
15.
15.
So 15 times 1 is 15. What times 1 gives 30?
30.
30. What times 5 gives 30?
6.
6. And 6 times 3, because let me do it on the
18.
side. Right, 18, right? So you're timesing that by 6, times that by 6. So you get 18. What times that gives 30 is 10. I'm just going up to time. So 10 over 30. And then this last one here, 6 as well. So 24. It's a little bit messy there, but now all you have to do is compare the numerators.
Yeah.
And whenever you get a one that's a little bit more challenging, that's what you want to do. And if you compare the numerators now, you can clearly see 30 is the biggest, then 24, then 18, then 15, then 10. And it's the same order, but once you have it that way, it makes it much easier, especially if you're dealing with fractions that are very hard to decipher. Now remember, the student book normally gives you easier fractions. The workbook, like I said, might have had 7/8, it might have had 15/16, it might have had 26/27, etc., right?
And the workbook, there is another one just like this, the same principle or dynamic,
right,
but the fractions are a little bit trickier.
Yeah,
So,
and that's what I mean. You might get something like that. So what Jacob said there is really important to know how to do, because these fractions are fractions we normally deal with on a day-to-day basis. They're easier to see. But the problem is when you get ones that are a little bit more challenging. So if you get those ones that are challenging, what you want to do is compare the denominators. Okay, so we don't have time to do every single one, but I do want to close out with number 6. We may not get to finish it. If we don't, that's fine. We'll just pick up on Tuesday. Remember, between now and Tuesday, you just want to read. If you didn't finish the workbook questions, finish the workbook questions. And when I put in the new worksheets, you just want to do those as well. All right, so for this one, if you are used to a tape measure, shouldn't be too difficult. If you're not used to using measurement tools, this might be a little bit challenging. Just to let you know, it was challenging to my morning class. So we'll see how you guys do if you are able to understand it a little bit faster and better. The directions say examine the information and number line, then read the question and use the drag and drop options to complete the answer. So once again, you'll be dragging the numbers in the correct positions. The following number line shows the interval from 0, that's the starting point, to 1, and they're each divided into 20 equal segments. In increasing order, list the fraction values of the points shown, reduced to the lowest terms. So that means this represents A, that represents B, C, D, and E. So what number should go in that first one?
20.
Okay, I hear 20. Does everybody agree?
So let's go back again.
Yeah.
Okay, I hear yes, and I hear some needs to go over it. So just take the time to quickly digest. I give about a minute, and then because it's 7:56, so I give about a minute just to get the idea. There are 20 segments here, right? A from 0 on is 20 segments that 0 to 1 is divided. If you're used to a tape measurement, the tape measure, some of them are divided into 16ths, some into 8ths. This one is divided into 20. And do you have an answer already for the first one? Someone said 1/20. And there are some questions like this in the workbook, so you do want to try those this weekend. If you're having any trouble, please make sure you go to the workbook. You'll see number 10 and 11 in the workbook. Number 15 and 16 in the workbook are very similar to this, so that will give you something to do. All right, I gave you about a minute. Number 1, I have 1/20. Does anyone agree with that?
Yeah.
Right, Daniel says yes.
I thought it's 1/10. I don't know.
All right, let's look at it. This is 0. A is going to be 1. And if that's a part of the whole, and there are 20 segments,
that's 1/20.
And it's 1/20. A represents 1 out of the 20. Think of it if it was pizza slices. If I had a whole pizza cut into 20 equal slices, and I took A is the very first one, I'll have 1 out of 20. If you look at B, that's 2, 3, 4. B is going to be 4 out of 20, but 4 out of 20 can reduce by dividing it by 4. And what does it reduce to?
1/5.
1/5. And that's exactly what you see in a tape measure. If you have a tape measure at your house and you pull it out, it's one of those fancy ones, you will see the fractions written there. All right, how about C? What is C going to be?
0/20.
I heard different ones.
0/20.
6/20.
6/20.
6/20. But that's not going to be our answer. Do you see any 6s here?
No.
Reduced to 3 out of 10.
We're going to reduce that one by dividing by the greatest common factor, which is 2. So you get 3/10. So you have to take the 3 and the 10 and drag them to
3/10. Okay.
How about D? What would D be equal to?
1/2.
1/2, right? That's 10 out of 20. That's halfway. So 1 out of 2. And E is already done for you. But just to show you, that's 11, 12, 13, 14, 15. So E is on the 15th part. The 15th out of 20, which reduces down to 3/4. If you look in your workbook, you will see similar questions to number 6. I want everyone to try that. I set the numbers, but I closed the book now. So just make sure you are practicing from the workbook. If you have not been practicing from the workbook, again, I thank you, Daniel, for going through those questions. It shows the type of questions that pops up in those workbooks. I said in the beginning, The workbooks do have more challenging questions, and that's why you hear me say no questions from the workbook, right? Because you should have questions from the workbook, and I'm glad you brought that up, Daniel.
Well, Mr. Ray, I don't think you made any of your, I don't think you did any of your lesson plan for today. We just went on to a whole different thing.
We did it. Yeah, I didn't. Because honestly, I didn't even know that was in the workbook. I've looked through the workbook before, but I don't recall seeing that. And so I was like, oh man, we needed to go over this, right? Because it's not in the student book either. So, you know, I'm glad that was in there because you obviously need to know that for the exam. And it's a good thing that came up. So this was a good bit of information. Hopefully your brains have been wreaked havoc in there and your brains are like, whoa, that's a good thing. It's no different than going to the gym. If you go to the gym and you come home, your muscles are hurting, that's a good thing. That means you're going to grow. That means you're going to have growth there and improvement. You're going to get better. So the fact that your brain might be like, whew, that was a long one, that was a lot of information, is a good thing. The question is, what do you do with all that information? Do you let it go to waste over the weekend until Tuesday? Or do you try to make sense out of it between now and Tuesday and have questions ready for Tuesday? Right?
Right.
So by Tuesday, you should go through that workbook, and I should expect to see some more questions, at least one or two, maybe on this, because as I listen, it seems like some might need some practice. So make sure you go through it. Do not be afraid to have questions. Even if you think the questions are too easy for me to answer, ask them anyway. All right? So there are no other questions. You are dismissed officially.
The homework?
The homework is to continue the workbook, and I'm going to have a worksheet up in the Remind.
Okay.
So continue the workbook if you haven't finished. Continue with the worksheets if you haven't finished. And someone had reminded me that I did not have division in the worksheet, so I just have to upload the last one. I obviously didn't get the last one up there. All right. All right, so just continue
Sounds
there,
good.
and hopefully you guys have questions. And so I'll see you guys hopefully on Tuesday. Enjoy your weekend with your families. Use your time wisely. Just divide your time up. Don't spend the whole weekend doing this, but just make sure you do some time out to do that.
Have a good weekend.
Thank you, Mr. Ray.
Yes,
Have a
you
good
are.
weekend, guys.
Bye.
Thank you, Mr. Ray.
Yes, you're
Bye,
welcome.
bye, everybody.
Yeah, have a great one, you guys.
You too.
Huh?